Okay, good morning, everybody. We are on our last lesson of this little unit. I know you probably don't remember what we did prior to our winter break, but maybe this lesson kind of will fill in those gaps because we use a lot of the same ideas from what we did about, 2 week and a half ago. But it's on similar figures. It's kind of just like a little way for you to get your brain going here. If you're noticing any patterns, I'm hoping you're thinking or you're seeing two things that are the same, right? Like I have two pictures of Justin Bieber, but one's big and one's small. I have two Snapchat logos. I'm not sure, but one's big, one is small. Same thing with Instagram, the red pepper. Brownie points if you guys can tell me who this is. This is our mayor, Brandon Bochensky. But all of this to say, similar figures are the same shape. So the same shape, but one is big and one is small. So they're different sizes. Here are just some real life examples for you. Oh, just kidding. I'll show you one thing. Okay. SpongeBob here. I think we're all familiar with SpongeBob. So I just duplicated him. So he is the exact same as the original picture, right? We would say these two things are congruent. They're identical twins. There's nothing different between them. Now, if they're similar, I'm just going to shrink it, right? They're still proportional. They're the same. But let's say they're not proportional, meaning it gets kind of wonky. Look what happens here. What happened? Nope, that's not what I want. Sorry, folks. There we go. Do you see how clearly they're not the same shape? It's the same person, right? But the sides aren't proportional. He looks all wonky. So that would not be similar. And we'll see what that looks like in a moment later when we get to some math. But we want your sides to be proportional so they look proportional to each other, right? Like if someone who doesn't look proportional, maybe their legs are way longer than their torso, you'd say they are unproportional. This is the blueprint of someone's floor plan, it looks like, their house. You would want this to be proportional to the actual house, right? So if they are thinking, here's the bathroom, I want it to take up this much of the house compared to the actual house, you'd want that reflected in this blueprint. This is here at school, right? If you walk up the stairs to the gym, we have these logos there. Now, this is just me, but this is, right, our logo for GFC. I don't think that this logo here is proportional to this. Like, look how tall it is. This is more square, that's rectangular, so I don't think that's proportional. I think they should have asked you guys to help them set that up because it's not done right, in my opinion. Mini brands, if you guys heard of these, maybe some of you got these in your Christmas stocking if your family celebrates Christmas. But these little mini brands would be proportional to the actual thing. Kind of fun. Okay, but here we go. Sorry to talk your ear off. Maybe it's because I missed you guys. So now we can fill in these blanks. Two polygons are similar if their corresponding angles are congruent. So you want your angles to be the exact same, and your corresponding side lengths are proportional, meaning they're not going to look wonky like SpongeBob. It's multiplied by the same number. So it's either going to grow by the same amount or shrink by the same amount. This little squiggle mark here, folks, indicates similarity. So that's what we would say. Again, more on that in a moment here. So let's look at our first problem. So it says ABC is similar to polygon EFGH. And now the order matters. We've done this before when we had our congruent chapter. So if we look, angle A is congruent to angle E. So you're going to put angle E. Angle B is congruent. Now what's my second letter? Angle F. Angle F. Angle angle C, we're just going to keep going right around, is congruent to angle G, our third letters. And then our last pair of congruent angles, angle D, is congruent to angle H. So we want our angles to be the exact same measure. But now you guys are smart enough to clearly see that clearly our sides aren't the same length. And we don't want them to be, so we don't necessarily want them to be congruent right now, we're just trying to show that they're similar. So we started with this bigger polygon, this bigger shape ABCD, and then we shrunk it to EFGH, right? We can clearly see that this one is smaller. So now we're just deciding what sides match each other. They're not congruent, so that's why I don't have a congruent symbol right here. We're just saying it maps onto. So we just know that they match. Okay, that's what it would map to. Oops. Sorry, folks. So if we look here, AB, let me erase this so we can see a little bit better. So AB would correspond to EF. Oh, we should have to. You guys put those on there? I messed up. All right, BC maps onto FG. CD maps onto GH. And our last one, DA, maps onto EH. Perfect. And that should feel familiar, right? Because we did something very similar at the beginning of December with our congruent figures unit. You know, you guys try this one with our triangle. So it says triangle PRQ is similar to triangle STU. Okay, I hope you pause the video, try it out, see if you can match on your own. But I'm going to start. So I'm looking here, angle P matches angle S. You're into angle S. Angle R, my second letter, matches angle T, my second letter. Angle Q, our last letter, matches angle Q. Again, when you put those little segment marks on there, folks, I'm sorry, those should be there, and I messed up. So if we look here, PR, my first two letters match ST, my first two letters. RQ matches TU, and QP matches US. Awesome. So now we're going to talk about, well, how much should we enlarge something or shrink it? It's kind of like you're dilating, right, from our chapter on transformations. How much should we shrink it, or how much should we grow it? So we call that the scale factor. And you guys remember that that was represented by the letter K in our transformations unit. So again, the order matters. So if it's asking you to give the scale factor, make sure you pay attention to which one you should list first. So it says, what is the scale factor from triangle ABC to triangle DEF? So we want to start with the smaller one and then go to our bigger one. So for me, this is what I like to do. I like to always just pick my smallest side. So if I look here in triangle ABC, my smallest side is 8. Now that has to match my smallest side on triangle DEF, which is 12. But now you remember you always want to reduce it. So if you forgot, remember in your calculator, you're going to hit 8, ABC, 12. And you should get 2/3. So the scale factor from the small triangle ABC to DEF is 2/3. What does that mean? It means that triangle ABC is 2/3 the size of our bigger triangle DEF. Okay. What's the scale factor from triangle DEF to ABC? So now we have the big one on top. So now, same thing, folks. I'm still going to start with my smaller side, because that's just easier for me, 12, over the smallest side on our other triangle, which is 8. And here we go. So again, 12, ABC, 8, hit equals. Now it's going to give you a weird fraction, right? It's going to say 1 1/2. Now hit ABC, oops, shoot, sorry. Okay, backtrack, sorry, rewind. So 12, ABC, 8 equals, now hit second, ABC equals, and it should get 3/2. And it should make sense. These should just be flip-flop of each other. So it was 2 over 3 for the first one when you went small to big, and it should be the opposite, 3 over 2 when you went big to small. All right, let's try some math here, folks. It says use similar polygons to find the value of the variable and the scale factor. So first we want to find x. Now don't forget about your code. Sometimes it's not so easy to tell what side goes with what. So I always like to start with my variable. So I'm starting right here, AB, so x. So now I gotta look, x is on AB. What does AB match? AB matches DE, which is 25. Is equal to, now come back to the triangle you started with, 28 over, now BC matches EF, which is 20. There we go. And now you have a problem you were solving right before Christmas break, or winter break, excuse me. So we're going to cross multiply. Do our little butterfly method here. So we're going to have x times 20 is equal to 25 times 28. Perfect. So now we're going to simplify. X times 20 is 20x. 25 times 28 is 700. And our last step is to divide by 20. X will give us 35. So 35 is the value of our variable. And now it wants the scale factor from triangle ABC to DEF. So we just have to pick matching sides. So let's start here. So should we use our x that we found? So we're going to have 35, and we know that AB matches, DE. So now we got to reduce. So remember, in your calculator, 35, ABC 25. Now we're going to get a weird decimal when the bigger number's on top, or a weird fraction. So it's second, ABC again, equals, and it is 7 over 5. So 7/5 is our scale factor. All right, good work, folks. Let's try another one. So here's our code. And we're trying to find the value of x. So I'm going to start there. So x, which is SR. SR matches ZY. ZY is 32. Is equal to, now we got to match, come back to the shape we started with. So we have 75, which is on PS. Now PS matches WZ. WZ is 40. There we go. And now we can solve our proportion by cross multiplying. So again, I like to always start with my variable. So x times 40 is equal to 32 times 75. X times 40 we know is 40x. 32 times 75 is 2,400. Then our last step is to divide by 40. So x equals 60. There we go. So now we want the scale factor from PQRS to WXYZ. So I'm just going to start with the variable we had, so 60. And we know that SR matched 32. Gotta reduce it. So 60, ABC, 32. We get another weird fraction, 1 7/8, so let's fix it. So hit second, ABC equals 15 over 8. Awesome job, you guys. Okay, last two. Same thing. Here's our code telling us what matches what. Start with our variable, so x. So GH matches DF. DF is 12. Is equal to, come back to the one we started with, 15. JH matches DE, which is 9. Cross multiply. 9 times x equals 12 times 15. We know 9 times x is 9x. 12 times 15 is 180. Divide by 9. X equals 20. Now we want to list our scale factor from triangle DEF to HJG. So we can pick whatever we want. Should we go with 9? We know 9, our red side matches 15. Type this in your calculator. 9 ABC 15 gives us 3/5. 3 over 5. Amazing. Okay, see how far you can get on this one. I know there's a little bit of extra information for you, but that's okay. See if you can figure it out. Start with your X and match your sides. Okay, I'm hoping that you tried it at least, but I'm going to start it now. So here we go. I'm going to start with my variable X. Now I look, RT matches JG. JG is 9. Is equal to, and now since you have a plethora of information here, you can pick. I'm going to go with 8. So ST matches HJ, which is 12. Now, if you use the 10 and 15, that's okay. You'll still get the same answer. But here we go. I'm going to solve now. X times 12 is equal to 9 times 8. X times 12 we know is 12x. 9 times 8 is 72. Divide by 12. X is 6. Beautiful. Now we want to give a scale factor from triangle RST to JHG. So I'm just going to pick X, which we found was 6. And we know that matches our side 9. So 6 ABC 9 equals 2/3. All right, folks, good job. Hold on, let me just see what your homework looks like so there's not any surprises. If there is, I can go through those with you. The front, you're just matching. You'll be just fine there. The back, you're solving like we just did, and there's an answer bank on top. You should be good to go. Thank you for watching, and I will see you later. Goodbye.